Hello, ladies and gentlemen, and I'm your Earth Science teacher, Mr. Stano, and today we're going to move on to crustal movement, or evidence of crustal movement resulting in earthquakes. Evidence of crustal movement can be seen by a number of different geologic features that we can easily pick up looking at any outcrops or rock layers. Evidence of crustal movement can be seen as tilting, folding, or faulting. And they're pretty easy. They're names just like they apply what they are. Tilting, we can see this upper movement, this slanting of the rock layers. The lines represent layers of rock. And you can see that one side has forced them upwards. Folding, we have pressure from plate tectonics pushing on either side, and it causes a straight line to become folded right here or to be bent. Faulting, usually resulting in some sort of energy release. We have our rock layers, and you can see here that this yellow line is now no longer corresponding with this yellow line here. One side was forced up, the other side forced down to either compression or tension pulling the land apart. We'll go on to tilting first. Here's a good example of tilting. We can see here layers of earth are uplifted on one side. And typically, as you remember from doing rocks, sedimentary rocks are normally deposited in horizontal layers. Here, you can see this tilting pattern. It actually shows up even better here, where we can see both horizontal layers and tilted layers. So we take a look. We have our nice horizontal sedimentary rock layers. And over here, we have tilted rock layers, showing a difference in sequence of events that led to the formation of this area. But nonetheless, we have these horizontal with some tilted layers up on top. Here's some more. Real prime example. We could follow these lines. Tilted. Okay, which brings us to folding. Folded rock layers. Very easy to see. We see them going along the New York State Thruway. How these layers of rocks that once straight are now bent due to extreme pressures from plate tectonics. Pretty much very similar to what we would see in regional metamorphism. And here we go, got it again. You can see here just how much rock layers or rock can be forced into positions that you would never expect to see. These layers right here, one straight, now completely U-shaped. Okay, some right here. Like I said, right along the thruway, we can see these. Anticline, same thing, these folded rock layers. And you can see from the description down here, basically we're taking this model and we push in on it, the compression from this way and this way, and it causes the land to buckle. Here's some more folding right here, right where this guy's standing. There it is. Just another example. Just to see these patterns that can happen when we subject rock to a huge amount of pressure, we can get it to do pretty much anything. Okay, overturning of layers. So much pressure, keep pushing, 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 we can actually get rock layers that were once straight to come back and over on top of themselves. So this would turn around here, this would finish this way. So this overturning of rock layers, once again, due to this extreme pressure, pushing, pushing, it buckles and goes in like this. And then it brings us to faulting. Faulting, we can see faults. They're going to be at the surface. They can, they're going to travel through into deeper layers of rock. But here's an example right here: a car that fell into a fault. Very easy to see on rock layers. We have the typical, horizontal fashion of rocks. And then we have this line streaking right through, showing that something was displaced. One layer moves up, another one down. Here we have multiple faults occurring in one region. 2, 3 faults in this area. So you can see how this rock layer matched up with this one. And over here, it appears that this one might have matched up with maybe one of these higher ones up here. So an extreme amount of movement can be seen with faulting.